Hello and welcome back to the 5.6 notes. This is a section on calculating antiderivatives using substitution. So when I first look at this example 2, what I notice I have this function as my integrand, 8x times cosine of 4x squared plus 3, okay, dx. Now what we've already gone ahead and given you the u, okay, the u is 4x squared plus 3. Now, the interesting thing is that if I take the derivative of 4x squared plus 3, I get 8x as my derivative, okay? So let me zoom in here real quick and let me rewrite this real quick and say, okay, I've got the integral of 8x times cosine, and instead of writing 4x squared plus 3, I'm going to write u, okay, dx, all right? Now, remember that we know that u is equal to 4x squared plus 3. So what I want to do is find the derivative, u prime, which is equal to 8x. Now, instead of writing u prime, I'm going to write du dx, okay? When I write du dx and u prime, they mean the same thing, okay? And this is equal to 8x, all right? Now, my idea here is that I've got these two parts of my integral that are in terms of x, and I want to get those in terms of u. So what I notice here is I've got du dx is equal to 8x. If I move my dx to the other side, move it out of my denominator, move it to this side, okay, you can essentially think of it as like multiplying by dx, but we'll cross that bridge when we get there. That goes away. So we are left with du is equal to 8x dx. Okay, so what I can do is I can now substitute 8x dx with what 8x dx is equal to, which is du. Okay, and so as a result, we get this. We get the integral of cosine of u du. Okay, and now I'm able to now take the antiderivative of this. Okay, this is in a form in which I can take the antiderivative. So the antiderivative of cosine is just going to be sine. So sine of u and then plus c. And then I want to resubstitute my u back in down here. And so my antiderivative in terms of x is going to be sine of 4x squared plus 3 plus c. Okay, and that's my answer. Okay. Let's take a look at example number 3. And this is, okay, so I've got the integral of x times e to the x squared dx, okay? And now we need to figure out what our u is, okay? On this example, they don't explicitly tell us what it is, so we have to figure it out. Now, what I want you guys to see is that I have this part here, x, times e to the x squared power. Now, this part here, my x squared, okay, what I notice is that's an inside function, okay, e to a function, all right? I also notice that I have a form of its derivative right here, okay? So if I do this, if I say let u equal x squared, I'm going to rewrite my integral, and I'm going to write it as x times e to the u power dx, okay? Now, what I want to get rid of in this example is x and dx. So what I want to do now is I want to go over here and take the derivative of my inside function u. And so if I find u prime, okay, that's going to give me 2x. Now, I don't want to write it like that. I want to write it in terms of, using my differentials like dx and stuff. So I'm going to write this as du dx is equal to 2x, okay? Now I'm going to move my dx to the other side, okay? So I'm going to move my dx to the other side. That goes away, and so we get that du is equal to 2x dx. Now over here, we need to get in just an x and a dx, okay? But I notice that I have this 2 over here, all right? So I have 2x dx. Now what I can do is I can divide this by 2, and so I get this statement that 1/2 du is equal to just x dx. Okay, so now what I can substitute back in, okay, I've got x dx is equal to 1/2 du. So I can come over here and I can say, all right, well, let me just replace x dx with 1/2 du. And so if I rewrite this as the integral of 1/2 times e to the u du. Now this is something I can take the antiderivative of, okay? Now one thing I can do is I can pull this 1/2 out front, okay? I can say that this is all, sorry, I need equal signs here, guys. I can say 1/2 times the integral of e to the u du, okay? And that's pretty simple, okay? So then what I want to do is I can now take its antiderivative. So I get 1/2, that's a constant multiple, times just e to the u, okay? The antiderivative of e to the u is just e to the u, and then plus c, okay? Now u, remember, was x squared. U is equal to x squared. So I'm going to substitute that back in down here and put this all in terms of x, and I get 1/2 e to the x squared plus c, and that's my antiderivative, okay? All right, let's take a look at the last one, something like this, okay? In an example 4, again, we are not given a u, so we have to figure out what the u is. Now we have a numerator and we have a denominator here. So what I see is you're trying to go, okay, which one's your u, okay? And we have those choices for you, that little list can help. But I always look for a function and then a form of the derivative of that function, okay? And it's not, this one isn't as apparent, but I see that I have a 2x squared. If I take the derivative of this, I'll get 4x. I'll get x to the first power, okay? So let's do that. Let's make let's let u equal just 2x squared plus 3x. So I'm going to come over here. I'm going to rewrite this now, and I'm going to say that 8x plus 6 over u, and then dx, okay? So the thing that I'm trying to replace here, the thing that I'm trying to get rid of is I need to get rid of this 8x plus 6 dx, okay? So up over here, I'm going to rewrite this now as du dx. The derivative of u with respect to x is now equal to 4x plus 3. Okay, I can move my dx to the other side, okay? So we get that du is equal to 4x plus 3 dx, okay? Now what I can do is I want to get 8x plus 6 out of this, okay? And I notice that 8x plus 6 is just both of these terms doubled, okay? So if I multiply this whole thing by 2 over here and this whole thing by 2, then I end up getting that 2 du is equal to 2 times 4x plus 3 dx. Okay, I can distribute my 2 here. So I get 2 du is equal to 8x plus 6 dx. So now 8x plus 6 dx, okay, is equal to 2 du. All right, so I can take 8x plus 6 dx and replace that with 2 du. So watch what I get here. Okay, I'm going to write my integral, sorry, need equal signs, as 2 du, or as 2 over u du. Okay? Now, again, this is kind of a little bit tricky to look at, but what I want to do is I'm going to pull that 2 out front. So I get 2 times the integral of 1 over u du. Now, this is something I can take the antiderivative of. I have a rule for this. Okay, so what I want to do here is I'm going to take 2 times, and this is the natural log of the absolute value of u plus c. Okay? And so, you know, that's all I got, all right? The antiderivative of 1 over u is the natural log of the absolute value of u plus c. So now I want to go back and plug in my u that we had. Okay, u is 2x squared plus 3x. All right, and so I would come back in here and I say that this is 2 times the natural log of the absolute value of 2x squared plus 3x, and then plus c. Okay, and that is integration by substitution, my friends. So this is a process, it is a procedure. It can be kind of confusing, but it does, it is another technique for us to use for integration, okay? So hopefully this made sense. It is now time for you to do a bunch of problems, so please get started on your homework, and we'll see you later. Thanks, bye.